Welcome to The Explainer. So if you've ever felt like AI companies are just vacuuming up your online data for free, well, you are in the exact right place. Today, we're diving into something really fascinating. The Codatta Core Architecture and assetification protocol. Sounds like a mouthful, right? But basically, if you've ever wondered how we can actually track, verify, and fairly compensate the real human beings creating the data that powers modern AI, this is it. We're going to break the whole thing down. We'll follow a single raw piece of data from the exact second it's created, all the way through its validation, how it gets packaged, and ultimately, how it gets monetized. Let's get right into it.
Okay, so here's our roadmap for today. We'll hit 5 key stops. First, the atomic contribution. Then, assetification and ownership. Third, storage, compute, and usage. Fourth, the royalty engine. And finally, governance and policy.
All right, starting off with Section 1, the atomic contribution, the smallest unit of work.
Okay, let's dive into this. At the absolute foundation of this entire system is what they call the contribution fingerprint, or CF. Think of this like an indestructible digital notary stamp. Every single time an atomic contribution is made, say submitting just one labeled photo of a street sign to train a self-driving car, exactly one CF is generated. It's literally the digital DNA for that specific piece of work. It is a tamper-evident record that perfectly binds together the what, the who, the when, and the why of the data. And here's the really crucial design choice. If someone comes along later and correct submerges that data, they absolutely do not overwrite this original record. Actually, scratch that. They couldn't even if they wanted to. Instead, the system emits a brand new CF that just references the original one. This guarantees that initial attribution is absolutely never lost.
Let's break down those 4 pillars of the contribution fingerprint. First, you've got the what. This is the content hash, which is basically a unique digital footprint of the data itself. Second is the who, the author's identity. And the cool part is you can sign this with your crypto wallet, so you're getting the credit you deserve without having to completely dox your real-world identity. Third is the when, a perfectly verifiable timestamp or blockchain block. And fourth, the why. This is the evidence and validations that tell us why this data is actually credible. Your reputation score, which naturally builds up over time based on your accuracy and skills, plays a massive role here in signaling trust.
Now, what's really interesting about this slide is how Codatta actually measures that trust. Notice how the data is categorized based on where it comes from. Like, is it a human self-reporting, or is it a machine learning inference, or maybe an on-chain ground truth? And then that source is paired with how it's validated, stuff like peer reviews or staked financial verification. This rich metadata is basically a measure of consensus. And again, validators don't mutate your original fingerprint. They just issue their own validation CFs that attach right to yours, creating this perfectly transparent history of agreement.
Which brings us to a really important question. We have all these brilliant, secure, isolated little data primitives, right? These contribution fingerprints. But how on earth does a single data point actually become a tradable economic asset that big AI companies can buy? Well, that brings us to Section 2, assetification and ownership, building provenance graphs.
This is where individual CFs are stitched together into version datasets. Because every single CF links back to its parent, we get this massive, complete provenance graph. But here is the real magic: tokenized ownership fractions. Imagine owning a fractional share of a massive hit song. But instead, it's for AI data. The protocol mints on-chain, transferable economic rights that map directly back to your contributing CFs. You literally own a mathematical fraction of the dataset you helped build. And to keep the data totally pristine, there are dispute and challenge windows. These act as built-in quarantine periods that safeguard the integrity of the data, allowing for any corrections to happen before any payouts are finalized. It's essentially a self-cleaning mechanism for data quality.
Moving on to Section 3, storage, compute, and usage, where Web 3 meets Web 2.
Now, the absolute crucial point here is balancing that undeniable trust with sheer performance. On the decentralized Web3 side, networks like Arweave, IPFS, and BNB Greenfield guarantee absolute immutability and provenance. It is the ultimate source of truth. But fun fact, if you actually tried to train a massive language model directly on decentralized storage, it would take an absolute eternity. It's just way too slow. So over in the cloud, Codatta uses what they call hot paths, like AWS and Google Cloud, for low latency reads. This hybrid approach means AI engineers can just use their mainstream tooling, like PyTorch or Hugging Face, with the blazing speed they need, but without ever losing that underlying Web3 audibility. It's totally the best of both worlds.
But, speed requires safety, which brings us to usage safeguards. The Access Gateway enforces token-gated edge policies, basically making sure only authorized people can even touch the data.
Then we have metering, which generates signed version-pinned billing events. But honestly, the unsung hero of this whole setup is the event effective timestamp. Whenever an AI company accesses a dataset, the system takes a snapshot at that exact millisecond. This ensures what they call replayability. So, if an AI company ever tries to argue about their bill, we can literally rewind the tape, replay the event with the exact same inputs, and get the exact same result. No fuzzy math, no arguments, for sure.
Next up, Section 4, the royalty engine, following the money.
Let's move to the payout phase and see how this all builds into a completely deterministic flow. Step 1. The data consumer, let's say it's an AI startup, pays into a revenue account. Step 2, the royalty engine, looks at that exact event-effective timestamp we just talked about. It pulls the attribution snapshot to see exactly who owned what fractions at that precise moment, and it executes the policy splits. This divides the money completely fairly between the developer margin and the royalties for the original data contributors. And step 3 is just a small treasury share to sustain the protocol itself. But guys, the absolute game changer here is the Train Now Pay Later model, or TNPL. AI builders essentially get a credit line for data. They can access it immediately, train their models, and pay the royalties out of their future revenue. It massively reduces friction for buyers while preserving all the upside for the data contributors. So, smart!
Finally, Section 5, governance and policy securing the rules of the game.
What you're seeing here are the system invariants. These are the absolutely unbending rules of Codatta. Traceability ensures we can always map served bytes straight back to the original fingerprint. Determinism guarantees payouts are mathematically precise every single time. Minimal disclosure protects user privacy. But the smartest feature, that would be revocability with audit. Let's say someone manages to slip some bad data into the system. The protocol can literally quarantine the revenue and recalculate everyone's payout fairly, all without destroying the underlying evidence. It allows the system to be flexible and correct itself without ever breaking that foundational chain of trust.
So look at what we've covered. We followed a single data point from a raw contribution to a tokenized asset, ran it through a high-speed hybrid cloud, and finally into an automated, totally transparent royalty payout. Codatta isn't just a technical architecture, It's a complete economic reimagining of data rights. Which leaves us with this final thought for you to ponder. As artificial intelligence relies more and more on high-quality, verified human data to evolve, who truly owns the future of intelligence? I hope this explainer has given you some solid tools to start answering that question. Keep learning, and we'll catch you next time.